Hello everyone, welcome back to another Planetarium live stream. It's great to have you all here for our first live stream of the new year. For those of you who don't know me, my name is Patrick Hess. I'm the Planetarium Manager at Union Station. And we're going to do a little star tour today. We're going to be looking at what's up in our evening skies. Actually, we're going to do a whole year preview looking at what's going on this year in terms of space and astronomy news. We'll be looking at constellations and all that, but also we're going to be highlighting some things to be excited for coming up over the next 12 months. And then we'll also be taking a retrospective look at the past year, our top highlight news stories from 2023, and some pretty exciting space discoveries mixed in there as well. So welcome back, everyone. For those of you who are a first-time watcher, we're happy to have you here. And we encourage you to please let us know where you're watching from in the comments. And, of course, if you have any questions throughout the show tonight, throw those into the comments section as well. It's always great to hear from everybody who's tuning in. For those of you who are returning watchers, welcome back. Thanks for all your support. This is our 98th live stream, and if you don't know, we do have a YouTube channel where we upload all of our past streams. It's youtube.com/KCPlanetarium, so after the show, be sure to head over there. And also be sure to subscribe to the Planetarium's own Facebook page, where you'll get all the news updates about space and astronomy and planetarium goings-on. Like I said, this is our 98th live stream. We've been doing these for nearly 4 years, and we're going to be wrapping them up, as at least in our regularly monthly scheduled programs over the next few months, leading up to our 100th episode and 4-year anniversary coming up probably at the beginning of April. So we've got Eric chiming in from Lenexa. Thanks for watching, Dad. Hope you enjoy the show tonight. Please ask any questions you might have. So we are only about 1,700 views away from breaking 350,000. That was kind of my personal goal for these live streams over the past 4 years. So hopefully we'll hit that pretty soon. A couple little announcements about the planetarium. The Arvin Gottlieb Planetarium at Union Station has a lot of exciting things going on. We do have evening laser shows on sale now. Tickets available for February shows. Here's our lineup coming up. We've got tickets available for all the shows, although Laser Pink Floyd Dark Side of the Moon is on its way to selling out. So be sure to snag those tickets if you want those before they're gone. So these are our most popular fan favorite laser shows that we're bringing back in the month of February. So if you're looking for something to do to get out of the cold and into the warmth of the planetarium and all of our lasers, then be sure to get those tickets. We've got 6, 7, and 8 p.m. shows available for 4 nights in February. Also, speaking of lasers, starting spring break on March 8th, that Friday, we'll be bringing back our fan favorite laser Taylor Swift, as well as introducing a brand new laser show, Laser Movie Magic, which is going to be featuring a lot of your favorite songs from some amazing movies from the studio of the Mouse. I'm not sure how much I'm allowed to say in regards to that. But if you're a big fan of music from movies like The Lion King or Frozen 2 or Encanto, Coco, Moana, Zootopia, and much more, there's a lot of awesome songs and laser lights to love in Laser Movie Magic. And don't forget that Disney 100, the exhibition, is coming to Union Station in May of this year. We've got Tammy, one of our all-time top fans, tuning in as well, saying hi from Iowa. And thanks for the congratulations about the Chiefs win, Tammy. Appreciate you. And I hope you're going to be cheering us on the next game as well. And we've got my dad asking if it's true that the imagery from the James Webb Space Telescope is producing information that is challenging our concept of the formation of the universe. Wow, I did not... just for all of our other watchers, I did not give him that little tip because that is a topic we're going to be covering later on in tonight's show. One of the most exciting discoveries last year was about our concept of the formation of the universe. So thanks for that great question, Dad. And I promise to all of our other watchers that he was not a plant. And my mom, Lauren, is watching from New Smyrna Beach as well. Hope you're enjoying the show. And shout outs to my granny, who I assume is watching as well. All right, well, at least my parents are watching tonight. For anybody else watching, please let me know in the comments. But it's always great to have anybody tuning in for our shows. So we're going to start out with a preview of what's up in 2024, some highlights about some cool astronomy events, and some other exciting things coming on, especially in terms of exploring our solar system. So stay tuned for that. My cousin Kevin is watching as well. And Ruth is saying, hey, thanks for watching tonight, guys. At least my family is supportive. All right, everyone. So let's jump into our number one excitement for this year, and it is a total solar eclipse. And that is coming up in April of this year, April 8th, 2024. The North American total solar eclipse is coming. And this graphic is a little bit fuzzier than I had hoped. But you can see in general that this eclipse, the path of the eclipse, will be covering a lot of the United States, coming up from Texas, going through the Midwest and up towards the Northeast. And so if you are anywhere in that path, and the conditions are right and it's not cloudy, you will see the moon completely block the sun and some other pretty amazing sights as well. So there is a website that NASA has prepared about the total solar eclipse that has some more interactive maps so you can actually see how that shadow is going to be crossing over parts of the country here. I guess I can't zoom in on that, but that's all right. So you can see the moon there just popping in front of the sun, and as that shadow starts moving across the country, if you happen to be in the right place at the right time, you will, for a very brief moment, for anywhere from a few seconds to a couple minutes, it will get very dark, and you'll be able to actually look at the sun without any eye protection. Of course, you never want to look at the sun, even during a partial eclipse, because it will damage your eyesight. But during the totality, as we call it, you will briefly be able to look directly at the sun and its corona, its outer atmosphere, that will be visible with the naked eye. Now, we do have a map from Missouri, so if you're in the area, you can see that near the boot heel of Missouri, there are a number of great locations to view the eclipse. This is from the Missouri State Park Service, I believe, so this is showing some state and national parks that you'll be able to, I think it's mostly state parks, so you'll be able to safely observe the totality in this yellow strip there. Cape Girardeau is a great spot. If you're looking for hotels, you may be out of luck at this point because a lot of them sell out years in advance, but check that out. But again, if you just pull over on the side of the highway, you'll be able to see this eclipse in its totality. Now, you'll be able to see a partial eclipse in Kansas City. You will not be able to view it safely without a telescope, without proper eye protection and solar sunglasses. But you can see that the sun will get pretty close to being completely covered, but not all the way. The sky will very slightly dim, but it won't really be very noticeable even at the point of most eclipse, which will happen at around 2 p.m. Central Time on Monday, August 8th. So if you're in the area and have access to some solar sunglasses, I know they'll definitely be on sale at the Science City store, and you can get them online too. Then you'll be able to observe the moon as it starts crossing the sun. So again, April 8th, very exciting. Another cool thing is if you happen to be in the path of totality, you'll be able to see 6 planets all at once, or at least 6 planets will be up. Uranus will not be visible with the naked eye, but Jupiter, Venus, Saturn, and Mars will all be visible, and Mercury will be right next to the sun, so you'll be able to catch that too. So pretty rare that all those planets will be visible at the same time during this eclipse, so that will be very cool. Now, if you're able to, you'll definitely not want to miss this total solar eclipse, because it will be a long time until the next total solar eclipse visible in North America. In fact, that next one will be in 2044, August of 2044 to be precise, and that eclipse will only be visible in the very northern parts of the country, and that will be a hard one to spot. But the following year in 2045, there will be another total solar eclipse that'll cross a lot of the country, going from the Pacific Ocean through California and the West, all the way down through Florida. So very exciting. And there you go, 2045. Mark your calendars. I bet there will be some pretty amazing pictures taken from Cape Canaveral of that eclipse when that happens. Hopefully with some next generation rockets. Oh, I'm just now noticing I've got sort of this heavenly solar flare behind my head. There you go. So these are all the total solar eclipses visible in North America over this century. So not a lot. Solar eclipses happen relatively frequently, around twice a year. The trick is you got to be in the right place at the right time, so it's more rare for them to cross the same place over and over again. So you can see these are all the eclipses that will be visible this century. So you definitely not want to miss those. Mark your calendars there. Now, speaking of planets, another preview of what's going on this year. Here is a map of all of the planet visibility throughout the evenings and mornings. So just basically you've got the planets here as rows, and then the columns show the months. And this will tell you when you can catch the planets. Now, of course, Uranus and Neptune, not visible with the naked eye. Mercury is also very hard to spot with the naked eye. But Venus, Mars, Jupiter, and Saturn are easy to spot when they're up. And right now, this month, we can see both Jupiter and Saturn in the evening sky. Jupiter is very bright. It's the brightest point of light right now, and it's usually the brightest point of light when it's visible. Venus sometimes outshines it when Venus and Jupiter are up. Saturn, on the other hand, is still up right now, and I'll show you where it is when we move over to our planetarium view. But it is going to be out of sight here by the end of the month, and we won't be able to see it in the evening until this fall. In fact, this summer will be kind of a planet drought. From around May through September, there will be no planets visible in the evening sky. They will all be visible in the early mornings, so if you want to do some planet observation, be prepared to set your alarm early for those summer views. But for now, you can still catch Jupiter and Saturn, my personal favorite planets to observe, that will be up. So let's now shift our focus to Stellarium. This is our planetarium software, and this is real time. This is the view right now, and the sun is already setting over downtown. We are standing on the steps of the Liberty Memorial here in Kansas City, overlooking Union Station towards the north, and we can see the stars are starting to come out. Now, we have since passed the winter solstice at the end of December, so the days are getting longer, and hopefully that will help us to get some warmer days, although the weather has finally warmed up a little bit from the crazy cold spell over the past few weeks. We've got my Uncle Jamie watching as well, saying congrats, Patrick, love your live shows, watching in New Smyrna Beach as well. Excellent. I didn't realize everybody was over there. Well, thanks, guys. I'm glad you're enjoying it. All right, and we've got my dad Eric saying, is lack of visibility of the planets in the summer typical? No, it's not, and it's basically just happenstance that all the planets are sort of grouped together this summer, which means they're kind of towards the same direction as we look into our sky. So we'd be able to view that. Let's see if I can get another view of our solar system. Oh, here we go. That works. Here is a 3D view of the solar system, and so we can see right now the position of the planets, but I'll just move our months a little bit higher. So if we look at June, we can see planet Earth right there. Well, we can see that a lot of the planets are all sort of in the same direction, kind of towards the sun over here. And so if we're looking sort of the other direction in our solar system from Earth, there are no planets. So all the planets just happen to be kind of grouped up. They're not totally aligned. When the planets align, we call it a conjunction, but they're all kind of grouped up. So we're just sort of unlucky this summer that all the planets are sort of close together and only visible in the early morning. But that's a good question. And there are cycles that the planets go through, but those take place over thousands of years. So this type of planetary grouping happens somewhat frequently, but not always with the same planets. All right, so we are looking at our night sky, and I'm going to give you a little preview of what we can expect to see this year, and we'll just kind of quickly go through different seasons and their constellation highlights. So in wintertime, as it is right now, I want to do a quick edit here to our viewing options. There we go. So I'm just going to go and throw up all the constellations here. There are a few constellations that are visible every season, and those are grouped together around Ursa Minor, the little dipper here, or the little bear. And that's because this star right here, which is named Polaris, is the North Star. So the North Star, Polaris, is directly above the North Pole, and since the Earth rotates around the North Pole as its axis, this star remains stationary in our night sky. And if I speed up time, you can see the stars are kind of moving around it, while the North Star stays relatively stationary. So I'm gone back to our early evening tonight here. But because of that, and because of our location here in the northern hemisphere, there are a number of stars that will remain visible. So any star sort of in this circle around the North Star that is at least above the northern horizon right now will remain visible year-round in Kansas City. We call them circumpolar stars or constellations. And as you can imagine, the farther north we go, the more of our sky will stay visible, the more of the sky will be circumpolar. So if you stood at the North Pole, the entire sky would stay up as it sort of rotated around you. But anywhere south of the North Pole, some stars will set and rise as the night goes on. So let's see if we can bring all the constellations back. There we go. So we can see Ursa Major and Ursa Minor, the bears here. Those are an example of circumpolar constellations. There's also Cepheus and Cassiopeia up here. They are circumpolar as well. They were the king and queen of an ancient African nation. But some constellations that are setting right now that will be out of sight as we approach spring will be the constellations Andromeda and Pegasus. Those constellations are part of the story of Cepheus and Cassiopeia. Andromeda was Cepheus and Cassiopeia's daughter, who they sacrificed to the sea god in order to stop terrible floods that were affecting their kingdom. There is a pretty cool deep space object near Andromeda. It's the Andromeda Galaxy. This is the closest spiral galaxy to our galactic neighborhood. It's often called our sister galaxy. It's a spiral galaxy like the Milky Way, and it is the closest spiral galaxy to us. All right. Oh, my grandmother Anne is asking, is that the Big Dipper or the Little Dipper? So we're going back over to north here. And so we have the Big and Little Dipper, which are two star patterns that are part of the constellations Ursa Major and Ursa Minor. So you can highlight those here. Ursa Major uses the stars of the Big Dipper. Ursa Minor uses the stars of the Little Dipper. So you can see the Little Dipper shape pretty obviously with Ursa Minor. But for Ursa Major, you can see the scoop there of the Dipper and its handle. And again, these two constellations are visible year-round. All right, let's see about getting these back up. All right, so again, we've got Andromeda setting this season. And the Liberty Memorial is kind of in my way, so as I always do, I'm going to go ahead and switch to a flatter landscape here. Another prominent constellation in our winter skies is Orion the Hunter. This was a famous hunter who angered the goddess Artemis when he boasted about his hunting skills. It is the brightest constellation in the night sky, though, so it's very prominent and easy to spot. And it's one of my favorite to observe, only really visible in the winter, though. But there's an amazing deep space object near the constellation Orion. Now, these three stars are Orion's belt, and then we have his sword hilt or his dagger down here. And this part of the constellation hides the Orion Nebula. The Orion Nebula is a stellar nursery. It's where new stars are born. And we actually dive in deep to the Orion Nebula during our current seasonal star tour at the Planetarium, so we'd encourage you to come check out our star tour at the Planetarium. It's a show called Sky Station Live. All right, well, I've got Rusty tuning in the comments saying you always do an awesome job with your live streams. Thanks for watching, Rusty. Excellent. So I've got my family and my fiance's family watching, and Tammy. I can always count on Tammy tuning in, but that's all right. I'm happy to have everyone joining us tonight. Rusty, let me know if you have any questions. You always ask amazing questions about space and astronomy, so I know you'll think of something great. So again, continuing our seasonal star tour, just checking out some highlights in our winter skies. There we go. Let's get these back up. We've got Gemini the twins. That's a fun constellation. It looks kind of like a pair of stick figures holding hands. These twins were named Castor and Pollux. They were a legendary pair of Greek heroes. Right. So that is our winter skies. What are the highlights that are up right now? Oh, I should also point out the Pleiades star cluster, which is on Taurus's back. The Pleiades cluster is sometimes nicknamed the Seven Sisters because some people can see 7 stars here with the naked eye. This star cluster actually contains about 2,000 stars. These stars are all siblings. They were born together from the same nebula. You can see the leftovers of that nebula reflecting their young blue light. There's a new story about the Pleiades cluster that we've been telling in our star tour, and I'll give you a little snippet of that. So oftentimes we talk about stars and deep space objects and their mythology in relation to mostly Greek and Roman mythology. But of course, there are many different stories and traditions from around the world, including right here in our own backyard. So the story that we've been telling lately is about is a Native American myth or folklore from the Lakota tribe. In the Lakota stories, they talk of, or one of their stories is about a group of girls who go out to play one day, but are spotted by several giant bears. The bears began to chase them, and so the girls tried to escape. They eventually found a big rock, and they climbed up on top of the rock to escape, and then they started praying to be saved. Hearing their prayers, the Great Spirit took the rock and lifted it towards the heavens. And although the bears tried to climb the rock, it was too steep and they slid back down, leaving behind huge scratches from their claws. The rock today can be seen as the Devil's Tower in Wyoming. It's a national monument, and I'm just going to pull up a picture of it to illustrate. Well, I was hoping the National Park Service would have a better picture, but we'll just pull up a good old Wikipedia. So there's the Devil's Tower, so you can see how you can imagine this rock rising into the heavens, and these big scratches could be from giant bears trying to climb it. And then in the Lakota stories, when the girls reached the skies, they were turned into the stars of the Pleiades. So pretty cool. I like bringing in some Native American folklore into our star tours, so I'm happy to share that story about the Pleiades cluster. So that is our current view, our winter views of the sky. But let's go ahead and fast forward things a little bit. So what I'm going to do is I'm going to pull up my clock here. And I'm going to speed up. I'm going to keep us looking at our early evening sky at around 8 o'clock. But I'm going to fast forward the days here. And we're going to, actually I'm going to just go forward in time a few months. So we're going to look at our spring skies. So you can see the sun is now up at 8 o'clock, so we need to fast forward just a little bit more to get that sun out of the way so that we can see our spring skies. So again, looking towards the north, we can still see the bears, although you can see now that Ursa Major is much higher in the sky as the stars have turned around. And we can still see Cepheus and Cassiopeia near the horizon, but Andromeda, there's her legs, she is setting. Orion will still be visible in the spring skies, but it'll be setting in the west. But there are some other interesting constellations that rise in the springtime, such as Leo the Lion. You can always spot Leo by looking for this backwards question mark shape, but you can kind of imagine there's his mane and his body and tail. There's also Virgo the Maiden, who looks like a big stick figure. Virgo represents a goddess of fertility and harvest. The Greeks called her Demeter, and the Romans called her Ceres. She's often shown holding an ear of grain in one hand, and that star in her hand is actually named Spica, which means ear of grain in Latin. Checking over the comments real quick, we've got Selen, who says, thanks for your valuable info. I appreciate you watching and commenting, Selen. We've got Holly and Connor saying hello as well. Thanks for watching, y'all. Glad to hear y'all are tuning in. Hope you're enjoying the show. By the way, back to Leo. That star at the end of Leo's tail is called Denebola, which means tail of the lion in Arabic. And then another very bright star can be seen rising in the springtime. It's this star down here called Arcturus. It means watcher of the bear in ancient Greek, and it belongs to a hunter constellation named Bootes, who was hunting the Ursa bears. Now, in the springtime, these few stars that we showed, Denebola, Spica, and Arcturus, shine very brightly, and they form a big bright triangle, and we call this the spring triangle. And as you see this triangle of stars rising in the early evening, you can see that spring is approaching. You can also find the stars Arcturus and Spica by using a little trick. Just follow the arc of the Big Dipper's handle across the sky, and you can see it will arc to Arcturus, and then you can keep following it to speed on to Spica. So again, from the handle of the Big Dipper, you'll just arc to Arcturus and speed on to Spica. Let's move right along and continue fast forwarding a few more months to check out our summer skies. And as you can see, in the summertime, even at 9 o'clock, the sun hasn't set. So we're going to fast forward even more to get that sun out of the way. Usually about an hour after sunset, you'll get what we call astronomical twilight, where the stars will be really bright. Because, of course, before the sun finishes setting, there's still a little bit of twilight that remains. And Jerry, one of our other longtime watchers and top fans, is tuning in and saying, thank you for sharing the Native American myth. Very interesting. Glad you enjoyed that one, Jerry, and thanks for watching tonight again. So we fast forwarded now to summertime. It is July. The sun has set around 10 o'clock. And looking towards the east, we can see another bright triangle of stars. And this is the summer triangle, another famous star pattern that you can use to track the changing seasons. There are 3 stars at the summer triangle. This star here is the tail of a swan constellation. There is the swan's tail. Its neck is between these 2 stars, and its wings are outstretched like this. The swan's name is Cygnus, and Cygnus represents Zeus, the king of the Greek gods, who often disguised himself as animals when he came down to Earth to mess with humanity. The second star of the summer triangle is this star here named Altair, which is the eye of an eagle constellation named Aquila. And then the last star of the summer triangle is Vega, which is near a little diamond in the sky, which represents a harp called Lyra. You can see those 3 stars of the summer triangle, signifying summer has arrived. Veronica in the comments saying, hello from Base Earth, thanks for watching tonight. Veronica says, we enjoyed the Sensory Sunday Planetarium showing. Excellent! I'm glad you guys enjoyed that. I really appreciate that we're able to offer that offering. So basically twice a month, we open the Planetarium and Science City for a special morning show where we bring the lights up a little bit and keep the volume down to make it friendly for our friends and guests who are a little bit more sensitive to certain sensory things. So we're really happy to provide that opportunity, and I'm glad you enjoyed that, Veronica. All right, so summertime is a really great time to check out the Milky Way galaxy, which hopefully you can see in your stream as this hazy band of light stretching across the south and eastern skies. In the summertime, we can see the galactic core where it is densest and brightest. I can probably also make the Milky Way a little bit brighter even. Yes, I can. So let's boost that brightness about twice as much. So the Milky Way galaxy is our home galaxy. We are about 2/3 of the way from the center to the edge of our galaxy, so it's much brighter in one direction than the other, which is why it's brighter in the summertime. We're facing towards the center in the summertime. There are 400 billion stars in our galaxy. About half of them are estimated to have planets around them, and these darker patches are clouds of gas and dust, called nebulas, where new stars are being born. Now in the summertime, there's a little star pattern you can use that'll help you find the Milky Way. It's called the teapot, and it's right over here near the southeast horizon in July. You can see the teapot's handle right here with its lid and spout. This teapot is actually part of the constellation Sagittarius, the Centaur, and that teapot's spout points right at the center of our galaxy. So that pointy spout points right at the center. And at the center of our galaxy is a supermassive black hole, which we recently took pictures of and have covered that on previous live streams. Also nearby is the constellation Scorpius, the scorpion, of course. The brightest star in Scorpius is named Antares. It's one of the reddest stars in the night sky. It's so red that sometimes people in the distant past would often mistake it for Mars. That's actually how it got its name. Antares means not Mars. So astronomers have always been very clever when it came to naming things. And that's our summer skies at a quick glance. Fast forwarding a couple more months and looking at what has risen in the east. We are already circled back around and we can see the Pleiades cluster starting to pop up there again. So that is just a little teaser of what's going on in our evening skies over the course of the next year. But there's other things to be excited about this year, so let's jump in. Let's take a look at a few highlights of things to be excited about for the coming year. And there are some exciting space missions that are in the books for this year. There will be the continued testing of the Starship rocket from SpaceX. Now, Starship is targeting a 3rd test flight in February of this year. The first 2 test flights occurred last year in April and November. They both occurred in RUDs, or Rapid Unscheduled Disassemblies, as they like to call them. The second flight took this giant space vehicle all the way to space for the first time, although shortly after the stage separation, the booster, the bottom part, exploded, which they had hoped to land back on the ground safely. And then the upper stage detonated itself before it reached its target altitude. But that's okay. After 2 tests, we kind of expected that to be the case. For comparison, the Saturn V rocket, which took astronauts to the moon, took about half a dozen or so uncrewed test flights, uncrewed and unsuccessful test flights as well, before we were able to send astronauts on board safely and take them to the moon. So space is hard, and this is to be expected. And this is important too. SpaceX is, of course, a private company, but NASA has contracted with them to assist in their plan to return to the moon, which we'll talk about later. So we wish SpaceX luck. We really hope that that rocket does successfully at least reach space and orbit. And then, of course, the lower stage, we would really like to land it back on the ground. But you can see the size comparison there. The Starship rocket is enormous. It's kind of deceptive because it's pretty simple. It looks sort of like a plain metal sort of can, for lack of a better word, but it is actually taller than the Saturn V rocket. And the SLS rocket, which is the rocket that NASA is designing to take us back to the moon. All right, and there are a few interplanetary missions to be excited about coming up this year. A Mars opposition is coming in early 2025. That's when Mars gets closest to the Earth in its orbital path around the Sun. And oppositions, as you might imagine, are great times to launch missions to Mars or to planets in general. And when Mars is in opposition, we of course would like to launch a mission to it. Number of missions, in fact. For example, there is NASA's Escape and Plasma Acceleration and Dynamics Explorers, or the ESCAPADE missions. So NASA sure does love their acronyms. So there are 2 satellites for this mission that are going to be heading towards Mars this year. And these 2 orbiters will monitor Martian space weather. They'll orbit on opposite sides of the red planet, and these 2 crafts will provide the first simultaneous stereo picture of how the solar wind interacts with the planet's upper atmosphere. Another notable thing about this mission is that it only cost $80 million, which may sound like a lot, but really, in terms of missions to space, this is pretty cheap. For comparison, the development phase of NASA's Maven spacecraft cost over $300 million alone, just the development phase. So for $80 million, that's a steal. Also, the Perseverance and Curiosity Mars landers from NASA cost upwards of $3 billion. So $80 million, that's dirt cheap. So hopefully this mission will be successful and we'll be able to learn all about Mars weather. India is also aiming to fly a Mars orbiter mission, and its launch date is scheduled for 2024 as well. And the European Space Agency had a mission planned to Mars in this year, but unfortunately it's going to miss that launch window and will have to launch during the next opposition in 2028. And perhaps most exciting is the Europa Clipper mission. Here's a flashy website from NASA all about this mission. So its launch target is 8 months from now in October of this year, and this mission will be looking for more information about Europa, an icy moon of Jupiter, which has vast oceans of water below its icy shell. As you can see, I'll just scroll through this. It's a really pretty website. So in 2024, I'll hide myself. This mission begins, and this spacecraft will hopefully determine if Europa has suitable conditions to support life. That is not confirming if it has life, but if it has the conditions for life. Europa has all the ingredients for life: water, chemistry, and energy. You can see that watery ocean below the ice of Europa. In fact, there's more water than Earth's oceans combined on Europa. And as we know, water is quite useful when it comes to life. So, pretty cool website. We can share a link to that website. But very exciting to observe. Hopefully this mission continues. I have not heard any updates that suggest that it won't miss its launch target. So that will be pretty exciting. And there are future missions to actually land on Europa and even explore underneath the ice to actually figure out if there is life on Europa. But for now, we will be continuing to learn more about Europa and its conditions to possibly support life. So those are some exciting news updates. that we can look forward to in the coming year. So hopefully all those launches are on target. There's one notable one that I left off, and that is the Artemis 2 mission, which was originally scheduled for this year. It has been delayed, and we will talk about that in our 2023 Space and Astronomy highlights. Selen is in the comments saying, are you going to share anything about our upcoming eclipses? I sure did. We actually covered that a little bit earlier, so you can watch a recording of this stream. But just a quick little summary. Basically, we are excited to witness the total solar eclipse covering North America on April 8th of this year. And here's the path of that eclipse going from Texas all the way to the northeast. And Missouri will have a number of locations near the boot heel that you'll be able to observe this eclipse from. And this will be the last eclipse to go anywhere in North America until 2044, and the last one to cross the United States until 2045. So mark your calendars, April 8th this year. We sincerely hope it is not cloudy. All right, so I realized I was hiding myself. Sorry about that. All right, so back to our highlights. So we're going to wrap up this stream by covering my top 5 news stories over the past year. What happened in 2023? We covered a lot of it during our monthly live streams, although our last monthly live stream was all the way back in October. And even then, we didn't really cover any news updates. The last official What's Up Star Tour was in August, so we've got a little bit of ground to cover, but I'm going to summarize and highlight my top 5 space stories from the past year. And number 1 is the Osiris-REX mission. On September 24th, 2023, the Osiris-REX mission returned pieces of an asteroid named Bennu safely back to Earth. You can see the return capsule there, sitting in the middle of the Utah desert. Now, this mission was launched in September 2016, so in total it took 7 years for this mission to come to fruition. This mission was launched in 2016, and it took 4 years to reach the asteroid Bennu. And on October 20th, it very briefly touched down and collected a sample of rock and dust from the surface of the asteroid before flying back off into space. Here is video footage of that moment. Pretty crazy that that happened so many millions of miles away. Now, due to parts of this probe being stuck during this 7-year journey, NASA scientists actually took a few months to develop new tools to safely open the container containing the asteroid samples without contaminating it, but they did. And here's a picture from just days ago, actually, a little over a week ago. NASA finally cracked this return capsule open and were able to access the samples inside. So there are rocks from an asteroid in space. The returned asteroid pieces will be divided now among sample analysis teams of 230 global scientists for a deep dive into Bennu's composition. NASA will keep at least 70% of the samples at the Johnson Space Center for future research to take place decades from now, hoping to take advantage of advanced technology in the coming years. So they're going to wrap it up, seal it up, put it in a Tupperware, and hopefully in the future we'll have technology to learn even more about it. We're actually still studying moon samples today because we've developed new tools to learn more about those samples captured 50 years ago. Bennu itself is a small near-Earth asteroid that makes a close path to Earth every 6 years or so. Scientists believe Bennu might have broken off from a much larger carbon-rich asteroid about 700 million to 2 billion years ago and drifted closer to Earth since then. Analyzing bits of the asteroid in a lab will help scientists piece together clues on the origins of the solar system. The final mass of the sample is going to be determined in the coming weeks, NASA stated, and we can't wait to find out more about the asteroid sample as we continue to uncover and discover its mysteries. My second exciting news update from last year is that there were a number of successful launches and moon landings. Most notably was India. They landed the Chandrayaan-3 a lander that set down on the lunar South Pole in August of last year. So congrats to their success landing on the moon. There were a number of attempted moon landings that were not successes. Unfortunately, Russia attempted a lunar lander and Japan as well, but both of them crashed. This year itself is not off to a good start, unfortunately. There was a U.S. spacecraft, the first actually U.S. spacecraft to attempt a moon landing in decades. It was called the Peregrine Lunar Lander, but its launch experienced a lot of troubles and it actually burnt up in Earth's atmosphere after the mission failed. And there's another Japanese lunar probe that did touch down successfully 3 days ago, but its solar panels aren't generating electricity as efficiently as planned, so we're not sure how successful that mission will be. But there were a number of other successful launches that marked a great year last year for planetary science. NASA's Psyche mission is now on its way to study a metallic asteroid, and the European Space Agency's JUICE mission is on its way to Jupiter. And there was another European Space Agency mission named Euclid that was just launched, and it's already returning spectacular images. Let's see if we can find some of those images. Yes, there we go. Where is it? There we go. So this is from the European Space Agency. Some first images from the Euclid mission. That's a pretty incredible picture, actually. This is the Perseus cluster of galaxies. So there we go. So Euclid, its mission is just starting, imaging some amazing galaxies. Oh, and even the Horsehead Nebula. That's a nice picture there. So this Euclid telescope, it's performing extremely well, and astronomers are excited to continue to use it as this mission is just getting started. It was built and operated by the European Space Agency, and NASA did chip in, but there are more than 2,000 scientists from 300 institutes in 13 European countries that are responsible for this mission. So we'll be following those developments in the future as well. Oh, there's a couple cool pictures from Euclid. There we go. Wow, nice. All right, so some successful launches last year. Some good news there. But what else has been going on? One of the most exciting stories, and this one's a bit more esoteric, but I'll try to summarize it as best I can. So last year, a universal gravitational wave background was successfully detected. And now, more than a century ago, Albert Einstein predicted that gravitational waves should probably exist based on his theories and calculations, but only in 2015 did we actually detect these gravitational waves using the LIGO Observatory, which stands for Laser Interferometry Gravitational Wave Observatory. Ever since in 2015, LIGO and other similar detectors have detected other gravitational waves, usually coming in short bursts, and these gravitational waves are produced by collisions of stellar mass black holes, or compact neutron stars. So essentially what's happening is black holes are colliding and combining, and they cause ripples in the fabric of space-time, and we are starting to detect them. But now LIGO and its counterparts detect rapid, minuscule length variations in gravitational waves. But the new observations announced last summer, in effect, use the entire Milky Way galaxy as their detector. So LIGO, they have like kilometer-long detectors that pass high-frequency gravitational waves through them. But if we could use the entire galaxy to detect gravitational waves, we could learn a lot more about them. And that's essentially what astronomers did. They used a number of pulsars throughout our galaxy to essentially bounce waves back towards us to learn about gravitational waves. So essentially, these gravitational waves detected are from supermassive black hole pairs all over the universe that are continuously stretching and squeezing our galaxy, albeit at very slow rates. But by observing these pulsars throughout our galaxy, we can detect that squeezing from these black hole mergers. It's sort of as if space-time was turned into the rippling surface of a swimming pool, as one scientist put it. So eventually, the reason we're excited about this is that gravitational waves will provide astronomers with a fascinating window on the properties and evolution of a wide variety of otherwise invisible black holes that we can't observe through these collisions, and by the fact that essentially instead of detecting these little one-off collisions of black holes, we have detected this gravitational wave background. So essentially, there are waves propagating throughout our universe from these black hole mergers happening all over the universe, throughout the universe's history. And it's pretty exciting. So basically, not only have we detected these black hole mergers all over the galaxy, but by using our entire galaxy as sort of this detector, we can start to process these astrophysical ideas at entirely different scales. So essentially, we have turned the galaxy into a giant satellite dish, and that's pretty exciting. All right, only 2 more news stories from last year that I'm going to cover. So if you've got any questions or comments, throw those in now. Like Rusty in the comments, who says, speaking of moon missions, I heard that our moon is actually moving away from the Earth slightly every year. You are spot on, Rusty. That is true. So a little bit of an aside to answer this question. Yes, the moon is moving away from us, and that is actually thanks to the Earth's oceans. So essentially, the reason the oceans have tides is because the moon is actually pulling on them a little bit. And so let's see if I can find an animation that helps to show that. Ooh, this one's from NASA. Perfect. Leave it to NASA to develop some pretty great little animations. So here is how tides work. So the moon's gravity is pulling the oceans, which causes them to bulge out in the direction of the moon. And they bulge out in both directions thanks to the forces of the Earth's, thanks to gravity, basically. I'm not going to get too deeply into it. But essentially, the moon pulls on the oceans. They bulge out here. And this was what causes tides. And so the moon orbits the Earth, and the Earth is spinning. So those tides are constantly moving. The tides come in, the tides come out. And so you can see how the tides change. And their timing is based on these different properties, both the Earth spinning and the moon going around the Earth. Now, there's a little bit of what we call tidal lag. You can see here in this last image, and I'm kind of in the way here. But so essentially, the tides are always a little bit in front of the moon, essentially, and are a little bit behind the moon. Well, depending on your frame of reference with the Earth rotating. But what's happening essentially is that there is a system of forces that are being transferred to and from the moon. So the moon is pulling the tides, but because the Earth is spinning faster than the moon is orbiting, the tides are moving a little bit faster than the moon. So the tides are actually a little bit in front of the moon, if that makes sense. But the Earth exerts a force of gravity on the moon, just like the moon exerts a force of gravity on the Earth. So what happens is basically energy is transferred back towards the moon because the tides are a little bit ahead of the moon. And that energy being inserted into the moon's gravitational system causes it to sort of float away from us. Its orbit expands as we introduce energy, the energy transferred from the tides, which are accelerated due to the Earth's rotation, and that energy introduced into the moon's orbit makes that orbit bigger, which makes it move away from us. So essentially, the moon causes the tides, the Earth's spin makes the tides transfer energy back to the Earth, moving that away. James is asking centrifugal forces affecting the oceans. Centrifugal forces and centripetal forces are very confusing, and there's a lot of debate on how to properly kind of explain that in the realm of physics. And I fully admit that I am not very equipped to explain how that all relates to each other, but there are aspects of centrifugal forces that are kind of introduced into the system too, but really, you can just see here that all of these dynamics of the oceans acting as their own center of mass, and then the Earth and the moon and the Earth's rotation moving the tides, and then we also have ocean currents and weather patterns. All these things are combining. But essentially, the main mechanism that is making the moon move farther away from us is that the Earth's rotation makes the tides always a little bit ahead of the moon, which causes energy to be transferred back to the moon's orbital location. Complicated answer to that question, but it was a great question. So thank you, Rusty, for asking. All right, so my next update is actually, I pulled this website. The exciting news from the Artemis mission to the moon. The good news, I should say, is that on April 3rd we announced the first. We announced the crew of the first human mission to return to the moon. So Artemis 1 was an uncrewed test launch of the Artemis rocket. And Artemis 2 will be the first mission back to the moon, although it will not land on the moon. It will just orbit the moon, just like Apollo 8 was the first crewed mission around the moon. They didn't land, but they orbited the moon. They have baby steps to get towards that eventual moon landing. Now, this crew, NASA has a big website all about it, and you can see them there. Just a little highlight, we've got Christina Cope, who is the mission specialist. They will make history as being the first woman to venture beyond Earth orbit and visit the lunar environment. They are native of Grand Rapids, and they became an astronaut in 2013 and served as the flight engineer on 3 different International Space Station expeditions in 2019. She holds the current record for the longest single space flight by a woman, which stands at 328 days. They've also done research work in Antarctica and Greenland. There's Victor Glover, the Artemis II pilot. He will become the first person of color to travel beyond Earth's orbit. Artemis II will be Glover's second stint in space, his first being a trek to the International Space Station aboard the SpaceX Crew 1 mission in November 2020. He's a Navy pilot and has been stationed in the United States and Japan, both for combat and peacetime operations. We also have Jeremy Hansen, the mission specialist. He is a Canadian fighter pilot who became a Canadian Space Agency astronaut in 2009, and he is currently one of only 4 active Canadian astronauts. By sending Hansen to the moon, Canada will become just the second country to send an astronaut beyond Earth orbit, so congratulations in advance to you, Canada. And then, last but not least, the commander of the Artemis II mission is Reed Wiseman. He's a decorated fighter pilot, and he joined at the NASA Astronaut Corps in June of 2009. He's been to space before, having served as a flight engineer for Expedition 41 in 2014, when he stayed aboard the International Space Station for 165 days. He's a Baltimore-born astronaut, and he was previously the commander of NASA's astronaut office. So for Artemis II, Reed and his crew will buckle up inside the Orion capsule and travel aboard the Space Launch System around the moon and back for a 10-day journey. There they are in front of the crew capsule. Now this mission will serve as a critical test of key technologies needed for the Artemis III mission, which will take 2 astronauts on a walk on the lunar surface. So Artemis III will be walking on the moon again. Artemis II will be returning to the moon to orbit it. And there's a cool poster. Now here's the bad news. So Artemis II was originally slated for this year, this fall, but actually just days ago, it was announced that both Artemis II and 3 have been pushed back. So the current launch estimate for Artemis II is September 2025, next year. During the early stages of the Artemis program, the Artemis II mission was originally scheduled for September 2022, and there were previous drafts earlier in the decade that had it launching even earlier, as early as 2019. So things get pushed back, so don't mark your calendars quite yet, and stay tuned. We'll definitely post all the updates on our Facebook page about the Artemis mission, but fingers crossed September 2025 holds. And then September 2026 would be the first crewed landing of the Artemis III mission. All right, my last news update is going to be our last web watch of the year and potentially ever. We are going to be celebrating what we celebrated in the summertime, which was Webb completing its first year of science. Now, it celebrated its first year of science with this amazing photograph of the Rho-Ophiuchi Cloud Complex, which is the closest star-forming region to Earth. It's about 390 light-years away. And in this highly detailed close-up, with no foreground stars blocking it, we can see a number of protostars, star systems in their early stages of formation, as well as approximately 50 other young stars that are just millions of years old, which is pretty young when it comes to stars. Now you can see this comparison photo from the Spitzer telescope. That was our last previously best image. You can see how much that image improved over time. So again, we celebrated 1 year of Webb's science, and there are a number of amazing discoveries that have been made thanks to Webb's mission. Also announced earlier last year around January was evidence that there were far more bright stars and galaxies in the early universe than previously expected. One amazing thing about Webb is that its imagery is able to peer deep into infrared wavelengths, which lets us look back in time, basically. The farther away we're looking, the more things are accelerating away from us due to the expansion of the universe. And so we need infrared telescopes to actually look back in time, because the farther away we look, the older the light is. So Webb is able to peer into the first few million years of our universe and see the very first stars and galaxies. And so far, thanks to discoveries made by Webb, we have already learned that our conceptions about the beginning of the universe are still in their infancy, and there are far more stars and galaxies than we ever expected at the beginning of our universe. So very exciting stuff. A lot of cool things that happened last year. And of course, you can always check out our previous live streams on our YouTube channel, youtube.com/KCPlanetarium, where you can find all of our other highlights from throughout the year. We did live streams mostly every month this year, or last year, where we looked at what's been going on around space and astronomy news. And Eric is asking, what is the objective of revisiting the moon? That's a great question. And there are a number of objectives. It's a little bit different than our first trip to the moon, which was during the space race when we were competing with Russia to get there first. There are a lot of people who think we are in another space race. China mostly is our greatest rival. They're building their own space station right now to rival the International Space Station, and they also have planned missions back to the moon. So we'd like to get back to the moon first, because as a country, we of course want to be the best, and we want to excite all the people of the United States and children mostly to be excited to learn more about space and technology. There are a lot of technologies that have been developed thanks to space exploration that we use here on Earth. So there are a lot of reasons why we want to go to space, not just to explore. A lot of those technologies help us back on Earth. There are, for example, different types of cancer research that are taking place on the International Space Station that can only take place in zero gravity. So there are a lot of reasons to go to space. There's the political, there's the science, and there's just the excitement. We hopefully will establish more of a permanent colony on the moon. And then the other advantage of that would be if we are able to live on the moon more permanently, we can build rockets on the moon. And it's a lot cheaper to launch a rocket from the moon than the Earth because there's less gravity and no atmosphere. And so it is sort of a stepping stone. The name of this stepping stone is a lunar gateway, where we hope to build space stations and surface colonies on the moon so we can launch future missions farther out into space, such as going to Mars. And there are other philosophical questions about space. You know, our entire race is, the entire human race is just living on one planet. So sort of as a backup, we might want to start living on another one just in case. Yeah, there are a lot of reasons to get back to the moon. And hopefully they will come to fruition in September 2025. All right, we're going to start wrapping things up. Holly in the comments says, it will be sad seeing you go. I will be sad too, but 4 years is pretty amazing. I've been working at Union Station almost 12 years, so my time doing these live streams will represent 1/3 of my career, which is pretty crazy thinking that these started all the way back in 2020. Christopher says, will the Planetarium be hosting the SpaceX IFT-3 when it happens? I need to look at what the current timeline for this is. If the next if the full stacking testing of, I assume that's what you're talking about, of the Starship rocket will hopefully be in February, because these launches are often rescheduled due to last minute weather changes. We generally don't plan any sort of in-person or live events for these, but we'll definitely be posting information about all the launches and other tests when they happen on our Facebook page, so be sure to head over to facebook.com/KCPlanetarium as well, and we'll be posting those updates. So if something really exciting happens, for the Artemis mission, for example, we'll probably do a little mini live stream to celebrate that, so stay tuned for that. Jerry says, thank you. Thanks for watching, Jerry. I appreciate all your support over the years. And my dad, Eric, says, end of an era. Thanks for all you have passed on. It has been my genuine pleasure, and it's not quite over yet. This has been the 98th live stream, but we have 2 more live streams on the books. We will probably be doing our 99th live stream on at the beginning of March, so mark your calendars, probably March 4th, that Monday. Hopefully February will be taken up by excitement for other Kansas City things. Go Chiefs. And then the 100th episode will be celebrating at the beginning of April, probably April 1st. I'm going to tentatively mark in the calendar that first Monday, where we will celebrate 100 episodes, hopefully 350,000 views. And we will be just taking a look at the past live streams, all the exciting things we've done. Over 100 shows. That's pretty crazy. Thank you to everyone who's continued watching, who's still watching now. And thank you, Jamie. We love your live shows, and I appreciate your support. I appreciate my family's support. Rusty, again, thanks for tuning in. Judy, if you're watching as well. And to all of our longtime watchers, Tammy, Jerry, and everyone else, we appreciate your support. To anybody watching for the first time, you've got 97 other shows available on our YouTube channel to check out. But for now, I will be signing off. I have been your Planetarium manager, Patrick Hess. Be sure to buy tickets for those laser shows in February and mark your calendars for Laser Taylor Swift and Laser Movie Magic in March. And we will see you next time for another live stream in March. Thank you all once again. Hope you have a wonderful evening and Happy New Year. And stay warm out there, y'all. Bye, everyone.